Hi, welcome to Dr. Pat TV. In this section, we'll be looking at limits. Now, before I begin, I must apologize to all math majors because when I'm going to work on this stuff, I'm not going to be so mathematically precise. I'm going to basically try to kind of get an idea of what's going on and just kind of work some of the problems and kind of talk a little bit about not too much about the theory. So if you want a theory focus, gonna have to find some other video. I'm gearing this one for business calculus students. Okay, so now limits. The key point before we do anything else is I want you thinking limits is all about the y value. We're going to know what the x is. It's all the question, what's the graph doing? What's the y value? All right. And on this, we're going to be estimating this as we get close to x. It's all in estimating, looking at patterns. All right, so let's take a look at this. For one of my examples I want to look at, I've got two functions here. And my first function right here, we're going to plug in -3. We're going to plug in 3. For my second function here, we're going to just plug in -3. Okay, so we're just going to do a quick little evaluation. When we plug in -3 for the first one, everything works out great. My calculator gives me an answer of -1. However, when I plug in 3 into this function, notice in the denominator here, in this denominator, if I plug in 3, it will make 0. Hey, can't divide by 0, so that creates a problem for us. Okay, so mathematically, we don't know how to divide by 0. And then for the second function right here, when I plug in -3, that's another case where the calculator is going to tell me it's an error because we're also dividing by -3. Now I have two examples here of dividing by 0, and what I'm going to do is later on here, when we look at these examples in more details, we're going to find out that, dividing by 0, there's a difference. I mean, some things happen, sometimes it blows up, and sometimes it's just a minor little difference there. And so that's what we want to look at is these kind of what situations we have when we're dividing by 0 and we're not allowed to, but things happen differently. Okay, so let's look at this first example. Something called a hole, we call a hole in mathematics. When I look at this function right here, I graphed it, put it in my calculator, got this nice little graph here. I kind of had to fiddle with the window. But when I did it, I'm noticing, see this little hole right here? Like the graph is just cruising along, but at x equals 3, we get a little hole. And the reason is because we're dividing by 0, so it's undefined. See, we can't use, our domain can't include 3. And so trying to plug in 3 makes a problem for us. But this graph's cruising along like nothing's wrong and then just jumps over 3. Okay, so now why is that? Why didn't things go wrong? And then the question becomes, hey, if I could, what would that y value be? What y value would I pick to make this graph just kind of like fill that hole there? And so that's kind of the idea of what we're going to be playing with. If we're cruising along this graph, what would be your pick for the point to be there? So I know the x value is 3. See, we know the x value. The question is, what's the y value? So let's see, 1, 2, 3, 4, 5. I'm kind of thinking that that's looking like a y value of 5. So if you just said, hey, Pat, how could you fill the hole? I'd say use the point 3 comma 5. And so we're going to use this idea here called limits. Limits are really great when things don't work for us, especially when we're dividing by 0. And so what we have is LIM for the word limit, not too original there. And then we've got this little x arrow 3 that just basically means the limit as x gets close to 3 or goes to 3. And then there's our formula. So we want to know what's the y value. What y value should we have when we get close to 3? This graph's cruising along. So it's cruising along and we're getting close to 3 from both sides in a way. You can go from either direction. And we're cruising to 3. What y value should we have there? That's what this whole mathematical concept's about. It's like, hey, if we've got a problem here, we got a gap, what should we use to fill it in? And so my guess was 5. Okay, so from the graph, that's what I'm looking at. Now, you might not think like, well, dude, how'd you get 5 from a graph? Is that really good? Let me show you the algebraic approach, and then hopefully will convince you that I'm not just kind of pulling something out of my hat kind of thing. Okay, and so what I'm looking now is the algebraic approach for limits. I've got this limit here. I'm good to go. And so now, what I want to do is I want to work this fraction. So what I want to do is I want to simplify the expression and then I'm going to evaluate. These are the two steps we have for limits. Okay, so what I'm looking at in the top part here can factor as x plus 2, x minus 3. So I can factor that top, and then hopefully you're noticing, wait, dude, that fraction has got an x minus 3 on top and an x minus 3 on the bottom. We can simplify those out. We can reduce those out, leaving us just the x plus 2. Okay, so now what we've done is we kind of put the band-aid limit in front of it, basically saying, hey, I'm going to work this expression. You and I both technically know we're not allowed to use 3, but once we're able to reduce this thing and we're able to, to kick out the problem was the denominator. Once we are able to reduce this fraction, I no longer have a denominator that's creating a problem for me. And when that happens, the technique is to evaluate. That second step is to evaluate. So now I'm just going to take that 3, this limit that we're doing, as x goes to 3. I'm going to take that 3, I'm going to plug it in for the x right there. And so that's where this 3 is coming from. And then I just evaluate the 3 plus 2 is the 5. And you see, it checks, it matches with the graph. And so this is the algebraic approach. What we're looking at, simplify and then evaluate. So let's take a look at another example of this. So I've got a new function called g of x. Clearly there's a problem at 2 because 2, when you plug it in, makes 0 in the denominator. So what I'm going to do, I'm going to take my limits. And again, what I'm going to try to do is try to do some algebra. I'm going to simplify and then I'm going to reduce. Graphically, if I were to look at this, these are tick marks of 1/4 here. So if I were to make a guess, I would make a guess of -1/4. And so from a graphical perspective, when we get close to x equals 2, my guess would be -1/4. If you do it numerically, what I'm doing here is I'm starting off with 1.5, then I'm getting numbers closer and closer to 2. Now remember, at 2, my calculator is giving me an error message. That's because technically I'm dividing by 0. But if I had a choice of what number to put in there, what would my choice be? So as I use x values that get closer to 2, notice and see if you can see a pattern of the y values. That's what this is about. We're looking numerically to try and see a pattern. And my guess is this, is that if I'm looking at these numbers and these numbers seem to get closer and closer to -0.25, which is a -1/4, which matches my graphical work. So my numerical pattern here tells me -1/4. My graph tells me -1/4. Let's look at the algebra and let's see what happens there. So in the algebra, when I factor the denominator, and then when I basically work this numerator, I'm going to factor out a negative because I want it to match the top if I can reduce. A 2 minus x is the same thing as pulling out a negative as -x minus 2. So that's what I did there. I now have x minus 2's that can reduce out. And so when those go out, I can now look at the limits of just this expression here. When we plug 2 in, we get -1/4. And so algebraically, numerically, graphically, everything's telling me that if we could plug in 2, the result that we would get, we should have, would be -1/4. But remember, we're not allowed to because we're dividing by 0. But the algebra, the limit concept, the theory allows us to kind of say, hey, what would the y value, what's the best y value that would work for us? And if we get close to, in this example, close to 2, -1/4 would be the perfect y value. Okay, so that's just a quick little introduction. I've got some more to talk about, some different examples to do. So this will just kind of start the idea on limits. Thanks.